Sorry. And it gets its units from this, right? Because this is a dimensionless ratio of velocities, right? It's all meters per second, right? Okay. And then receding, the receding would be, the frequency would be 440. And then, of course, it's 43 minus 27. 440. I'm just actually going to go second entry. I'm going to make that minus 405. And again, this is another different answer, right? Okay, let me show you a couple things, and then I'll have you guys try to whiteboard this. Okay, but the first thing I want to show you is she really asleep though? Right. You gotta wait till she's sound asleep. Get comfortable. Yeah. He is sort of sleepy, yeah. Okay, good enough. But the key though is you don't want to really change what you're saying, right? You just want to keep the same sort of level of conversation going. Because it's, you know, it's the frequency is what's important, right? Because as you talk about things, right, you just got to keep sort of talking about things, right? They just had noticed that you were having arousal control, so. Okay.
Should have recorded that.
Yeah. Well, you know, some people don't have their minds in the gutter, so go figure, right? All right. Check this out. Somebody wrote a very neat program. Oh, just run it. All right. They wrote a really neat program. This is showing moving source Dopplers, showing the actual shortening of the wavelength, right? So that's kind of cool, right? That is kind of cool. It's very, very, very hypnotic. You will vote for Democrats. I'm just kidding. Okay. And then I can, of course, make it go faster and faster. And as it approaches the wave speed, then this in front, the frequency gets higher and higher, doesn't it? Yeah, the wavelength gets shorter and shorter. The frequency gets higher and higher. And you can do that to a point, right? It's like, right? We're approaching. It's like, and at this point, it's really the waves are just barely getting out in front. So don't you hear an incredibly high frequency? Yeah. What if I go exactly the speed of the waves, which in this case is 80 something, right? Can the waves get out in front of you? No, so what do? They can spread off to the side, can't they? But they can't go in front of you. And so all of the crests that you would have made have piled on top of each other. Yeah? And you get a frequency of, well, let's look at this. If these guys are equal, what's your frequency? Well, you know, it's undefined. You can't divide. But if you divide by something that's almost zero, what do you get? Infinity, don't you? Doesn't it approach infinity before it becomes undefined? Yes? Okay. Yeah. So basically, if you go the source speed, you generate this. What is it in sound? When an airplane does that, what is it? What is all the pressure waves piled up on top of each other? What does it sound like? It's a boom. It sounds like a cannon going off when you hear it. Okay, and what it does, let's just make an airplane that goes way faster than the speed, right? Let's make the wavelength shorter so we can see it, right? what it does is it sheds off. If this is the airplane, right, the sound is shedding off the back in a V shape like that. Does that look like a wake of a motorboat?
Yeah.
Yeah, that's because the wake of a motorboat is exactly the same thing on water. Yes? The wake of a motorboat is to a motorboat going faster than the ripples of water, right, as the sonic boom is to an aircraft, right? Only if on an aircraft, of course, it's three-dimensional, isn't it? It's a cone. It's not just a V, right? But what you're seeing here is a cross-section of it. So what your experience, if a supersonic airplane flies by you, your experience is this. First, you see it go past you without hearing a sound, correct? In the same way that a motorboat can go past you and you don't even see any disturbance in the water, right? Because the wake hasn't hit you, right? Then at some point after it's gone by you, you hear all of those pressure waves that would have gone ahead of the jet had it been going slower than the speed of sound all at once. And that's the boom. And then when you're in the wake of the jet, of course, behind that, once it goes past, you hear the Doppler shifted low frequency of the jet, kind of a rumble. Yeah?
So if you're in, like, say you're right behind this thing, kind of, like,
yeah.
But no, but like kind of in the tone, do you hear any sounds things making?
Yeah, if you're following the jet, you're just going to hear the jet. If you're moving along with the jet, you hear.
But you'd be like, if it moves out in a cone, one should be like in a space on the inside where it's kind of.
Once you get behind here, you hear the jet. Notice that there are waves behind there, right? You hear it. It might be Doppler shifted, especially if you're sitting still, right? But it's not going to be nothing, right? You're going to definitely hear it. Let me just, rather than talk about what you would hear, let me just show you what you would hear, because I've got videos that somebody. Okay. This one has some adult language in it, so I'm just warning you about this. Boom! There you go. What did he say? Right? Yeah, so you see the airplane go by you, and then once it's past you, you get hit by the wake of the airplane. The sonic wake, which is the boom. It goes past you, boom, you get hit by the wake, right? From that angle, you could calculate the speed of the jet, can't you? The faster it goes, the more V-shaped it is, right? Yeah? Okay, let's go back to here. Did you get it? Good. I've heard this one before. Okay, now watch. As it goes by, you can actually see the thing breaking the sound barrier right there. See it? And you know why it does that, but you just don't know you know. There's things you know, and there's things you don't know that you know, but you know. You know?
I got it.
What is that? That's it. Actually, at that point, it was just subsonic, and then the pilot pushed the throttle forward and broke the sound barrier just as they went by. And when they break the sound barrier, of course, that's when the shock wave, you've got that big shock wave right there parallel with the airplane, right? Now, what happens to the air when the shock wave goes past? It gets high pressure, and it goes from high pressure to low pressure, doesn't it? It's not just a high pressure front. It goes from high pressure to low pressure. That's why it hurts your ears so much, right? It's making, right, that's what the motorboat wake too. It isn't just a crest, it's also a trough, isn't it? It's like a big crest, big trough is what a motorboat wake is, right? So in that trough here, isn't that low pressure? What happens if you suddenly drop the pressure of air? I did this inside a bottle. It does what? Any moisture in the air condenses. This is called adiabatic expansion. I demonstrated this with a bottle. Do you remember that? Yes. Okay. So when you see that going on there, basically the airplane is becoming an air conditioner, a refrigerator, right? It's compressing the air, which makes it hotter, and then right behind that, it expands it. And of course, this is right above the water. I don't know if you noticed, they're shooting this right above, the airplanes are flying above water, right? So the air is already 100% saturated, and then if you cool it down, of course, it condenses, right? So watch that again. I've got a better one, though. It's like, wait for it. Did you get it? Good. All right. Okay. Okay. And then this one is great because they basically, here they are above the water. They do slow-mo. Watch. See right there. Isn't that wild? So this was fact that this